So good morning, everyone. I want to welcome all of you, grade 11 students, parents, and visitors to the virtual math exhibition for the academic year 2020-2021. I was happy and satisfied with most of the work, and I tried as well as you did, and as much as I can to improve. What can we improve? I know things were not easy, as most of you were working far from each other, but this was passed mostly by online meetings that we did together as groups. So I want to say thank to all of you for all the efforts you did, and hope that all of you learned something from doing such a project. So now we will start our math exhibition with a short video from Dr. Nigat, our math department HOD, also head of assessment and SLT member. So I will share my screen with the Dr. Nigat video. Please remain mic off all the time.
Good morning. Assalamu alaikum everyone. Dear students, teachers, SLTs, principal, HODs and parents. Welcome to Virtual Math Exhibition 2021. The goal of NAR's Math Department is not to increase the amount of knowledge, but to create the possibilities for a child to invent and discover, to create men and women who are capable of doing new things. Education is not the learning of facts, but the training of mind to think. Children must be taught how to think, not what to think. This event provides the students the opportunity to showcase their creative abilities while reflecting the skills they learned during their math lessons. Good luck, students.
So, as we have 4 projects from grade 11B, this means we will have 4 videos. We'll start displaying the videos now, and now we'll start with video number 1 for group number 1.
Hi, today we are going to present our math exhibition project, which is based on lesson 4.1 circles. We chose our group name 360 based on the degree of the circle, which is 360 degrees.
The reason of choosing this topic, we picked lesson 4.1 circles since we imagined that seeing how circles are formed is important to take care of genuine issues. For example, telescopes rotating the Earth. Circles play an important role since our solar system is in a circular shape.
What is a circle? A circle is the locus of all points equidistant from a central point. This means that a circle is made up of all the points that are the same distance from the focus or the center. The point from the side of a circle to the center called radius, and the point from one side to another side, and the line is passing through the center called diameter.
The history of the circle. The study of the circle goes back beyond the recorded history. The invention of the wheel is the fundamental discovery of properties of the circle. The Greeks considered the Egyptians as the inventors of geometry. Ahmes, who is a scribe and the author of the Rhind Papyrus, gives a rule for determining the area of a circle that corresponds to 256/81, or approximately 3.16. Thales found the first theorems relating to circles around 650 BC. Euclid's book, the third. Euclid's elements set to work properties of circles and problems of inscribing polygons. One of the problems of Greek mathematics was the problem of finding a square with the same area as given. Several of the famous curves were first attempted to solve this problem. Anaxagoras in 450 BC is the first recorded mathematician to study this problem.
Explanation of the concept. There are two main equations for the circle, the standard form and the general form. The standard form equation is x minus h squared plus y minus k squared equal r squared. In this equation of the circle, we can easily identify the center of the circle, which is h and k, and the radius, which is r. And the radius is always positive. For an example, x minus 2 squared plus y minus 3 squared equal 4. Now, a common mistake that people do is they take the center, which is h and k, as it is with their same sign. But in this equation, we need to change their signs. We need to do the opposite. Here we have h equal minus 2 and k equal minus 3. We will flip the signs, which will become h equal positive 2 and k equal positive 3. So the center here is 2 and 3, and the radius is r. Since r squared is 4, so the square root of 4 equal 2.
Explanation of the concept. Now we are going to explain the general equation. Example, x squared plus y squared minus 6x plus 4y plus 9. First, we should put the x-axis all on one side and all the y-axis on one side, and 9 we should take it outside. So 9 will be negative 9. To find the missing number from the x side, we should divide the number with x, which is negative 6, divided by 2. The answer that is given, we should square it. So negative 6 divided by 2 equal 3, negative 3. Negative 3 square root equal 9. 4 divided by 2 equal 2. 2 square root equal 4. These two numbers that we found it, we should add them with the number that is outside the equal. So when we add them, negative 9 plus 9 plus 4 is equal to 4. Okay, now how we can find the center? First, the number we found it on the x-axis is 9. We should square root 9, which will be 3. Positive 3, we're gonna change to negative 3. 4, we should square it, it will be 2. So from 2, we should change it to negative 2. Okay, the center will be 3, negative 2, and the radius is r. Since r squared equal 4, r square root 4 equal 2.
One real-life application is the Ferris wheel. All the points along the outer rim of the wheel are equidistant from the center. The lights on this one can help you see a little easier. Another real-life example of the application is the bicycle wheels. Circles are the best shape for a bicycle because they roll very easily around, and the center point would be h and k. In the equation, all the points along the outer edge would be x and y values. The radius could be represented by the bars supporting the wheels that run from the center to the outer rim. Tires of different vehicles can have different radius. The circumference of a ring needs to match the circumference of the finger, which is one good for a good fit.
The radius of a curvature of a camera lens can be used to determine its focal length, which is the distance from the lens where light rays will focus. Also, pizza and cake size are determined by the diameter of the pan in which they are baked.
In the poster we were assigned to make, we included the two main formulas of the circle, which are the standard and the general, as well examples for both of them, as well as real-life examples and the reason of choosing this topic.
Here are some real-life applications that we found around our house. This is an art piece. They use the ruler to determine the diameter, and we can determine the radius from this ruler. Artists use this method to perfect their art piece.
Or even we can use the baking pan, which is circular baking pan. The bakers, they use this pan to know the radius and the diameter of it. Why they use it? To prevent it from looking lopsided or uneven. Thank you for listening. We wish that you enjoyed our project.
Considered the Egyptians as the investors of geometry. Athens who is
عادي عادي.
لا عيد النوع عيد تعرفون شيرتي طاحت بعد شيرتي
ما تبينين
أنا سويت ستوب. استغفر.
إذا عادي طرشت الفيديو نقدر نسوي في اي موفي، يعني نسوي
زين خلاص يلا بمسح عقب نمسح اللي في البداية.
بداية
يلا صبري ما أعرف لازم أمسح.
take care of genuine. أقول لكم أنا اليوم
I learned how to find by the general equation, and I faced difficulty in finding the radius of the circle by using the distance formula.
I have learned that circles play such an important role in our environment, and that we can find the radius of the circle by the use of the general formula as well the standard, but I faced some difficulties in using the general formula more than the standard one.
We all used to make a Zoom meeting to discuss our project and to give everyone her work. We all have fun. We learned many things as how we can use circle in our real life example and the things that we have in our home. We face some difficulties in the timing of making the meeting, and that's all.
I want to ask the leader of this group to give us a brief reflection again for the whole group about the project. So I'm sure guess that Sarah is the leader of this group. So can Sarah please tell us a brief reflection about the project?
Mr. Sarah can't talk, so I will talk.
Okay, Rodriel, go ahead.
Do I open the camera?
As you like. Yeah, it's better to.
We've chose lesson 4.1 circles because we believe that circles are important in our life and that we need to understand them in order to solve many problems. We have found some challenges in using the general formula for finding the center and the radius for the circle. We've learned that circles are not just shapes, but they play an important role in our life. The real life applications that we found are many. Some of them are the Ferris wheel and the bicycle wheel. As it's been said before, that circles are really important. We can include them in many other future projects and improve our work by solving questions and finding the center of the circle by the use of the general formula.
Thank you very much. Directly we'll move to project number 2 as we are using the time. So we start now with the project number 2 here.
And we are presenting our math fair project. Hi everyone, we are grade 11B students and we are presenting our math fair project. The topic we chose is trigonometry in our lives. Our group name is the 6 functions because the 6 functions are included in our topic, which are sine, cosine, tan, tangent, cosecant, and secant.
We chose this topic because we believe that it suits us. We also believe that it's important simply because it is used in naval and aviation industries. It is used in cartography, which is also creation of maps.
Trigonometry can be used to roof a home, render the roof inclined in the case of single-family bungalows, and calculate the height of a building's roof. Among other things, it's commonly used in the naval and aviation industries. It's a form of cartography, which is the creation of maps. Trigonometry is also used in satellite navigation systems.
Trigonometry is derived from Greek words trigonon, 3 angles, and metron, measure. Trigonometry is the branch of mathematics which deals with triangles, particularly triangles in a plane where one angle of the triangle is 90 degrees. Trigonometry specifically deals with relationships between the sides and the angles of a triangle on the trigonometric functions and with calculations based on these functions. The history of trigonometry is the origins of trigonometry can be traced to the civilizations of ancient Egypt, Mesopotamia, and the Indus Valley more than 4,000 years ago. Some experts believe that trigonometry was originally invented to calculate sundials. The first recorded use of trigonometry came from the Hellenistic mathematician Sira in 150 BC. Many mathematicians like Aryabhata, Ibn Yunus, and Al-Kashi also contributed significantly.
How is trigonometry used in real life? As we mentioned before, trigonometry can be used to roof a home, render the roof inclined, in the case of single-family bungalows, and calculate the height of a building's roof. Among other things, it's commonly used in the naval and aviation industries. It's a form of cartography, which is the creation of maps. Trigonometry is also used in satellite navigation systems. Who first invented trigonometry? Trigonometry in the modern sense began with the Greeks. Hipparchus, 190 till 120 before the Common Era, was the first to construct a table of values for a trigonometric function.
Why is trigonometry important in our society? Trigonometry is used by architects, draftsmen, engineers in all fields, pilots, game makers, and even chemists. A working knowledge of trigonometry and its applications is vital for students of all ages, since it is one of the most important fields of mathematics, particularly for professions that rely on calculating angles. Here's an example of using Heron's formula. The formula is A equal radical S bracket S minus A bracket S minus B bracket S minus C bracket is used to find the area of an oblique triangle.
Those are the trigonometric ratios. Sine goes with the opposite side over the hypotenuse. Cosine goes with the adjacent side over the hypotenuse. Tangent goes with the opposite side over the adjacent side. Cosecant goes with the hypotenuse over the opposite side. Secant goes with the hypotenuse over the adjacent side, and cotangent goes with the adjacent side over the opposite side. Those are the values of trigonometric functions, as you can see in the given table.
Angle of elevation. In this diagram, X marks the angle of elevation of the top of the tree as seen from a point on the ground. The angle of elevation is always measured from the ground up. It is an upward angle from a horizontal line. It is always inside the triangle. You can think of the angle of elevation in relation to the movement of your eyes. You are looking straight ahead and you must elevate your eyes to see the top of a tree. When trying to remember the meaning of an angle of elevation, think of an elevator that only goes up.
The angle of depression. In this diagram, X marks the angle of depression of the boat at sea from the top of the lighthouse. The angle of depression is always outside the triangle. It's never inside the triangle. It's a downward angle from a horizontal line. You can think of the angle of depression in relation to the movement of your eyes. You're standing at the top of the lighthouse and you're looking straight ahead. You must lower your eyes to see the boat in the water.
Notice how the horizontal line in the angle of depression diagram is parallel to the ground level. The fact that horizontal lines are always parallel guarantees that the alternate interior angles are equal in measure. In the diagram, the angle marked X is equal in measure to MBAC. Simply stated, this means that the angle of elevation equals the angle of depression.
As a real-life example, the Pyramid of Giza. Primitive forms of trigonometry were used in the construction of these wonders of the world.
All in all, trigonometry is a branch of mathematics with several important and useful applications.
Hence, it attracts more and more research with several theories published year after year.
In reflection, trigonometry allows us to use ratios that are associated with any angle ABC, so we can calculate a broad range of heights without having to measure them. We learned about 3 important ratios, for an angle, sine shortened to sin, cosine, cos, and tangent, tan.
Yes, I also learned that trigonometry is used to measure like the height of things such as mountains or roofs. Also, I learned that there are different branches of trigonometry, such as trigonometry in aviation, trigonometry in criminology, and trigonometry in navigation. There's a navigation and navigation. There's many more, but those are the ones I learned about. We also had fun while making the project. صح خديجة?
Yes, we
Didn't
also
we?
learned many different ways, such as roofing a house to make the roof inclined in the case of
Yeah,
single individual bungalows, and the height of the roof in buildings.
it was a fun topic, and we did face some difficulties since
Yeah,
Khadija is an online learning
yeah,
student and I'm a campus learning
campus.
student. Yeah, but we managed to make the project. It was a bit challenging, but we managed to do it. And yeah,
Yeah,
that's all
thank
for
you.
today. And we hope you have a good day.
We hope you
Bye.
enjoyed.
I guess that I closed before see the model, so I'll try again to open and see the model. Sorry for this. Maybe there's something important we want to see, so let's see. I will come back to this at the end. Let's move now to coming in project number 3. Uh,
Hi everyone. For today's math fair, we have chosen the topic transformation of functions done by the group XY. Why we chose this topic? Geometry is present in almost everything we see on a daily basis. We deal with it every single day and sometimes we're unaware of it. Now that means it plays a really huge and significant role in our lives. Transformation covers 4 major topics that are rotation, reflection, dilation, and translation. Now, a lot of people seem to be uninterested in how and why they're addressed in our life. And as a result of that, we choose this particular subject to cover those 4 topics and that deep dive into each and every one of them and see how they are related to our daily life experiences and how we use them. The history of transformation of functions. The influence of Euclidean geometry had been questioned by non-Euclidean geometry and projective geometry by the late 19th century. Felix Klein, a German mathematician, made the first notable attempt to reorganize the ponder of geometry, which was published in Erlangen in 1872. Klein suggested in his Erlanger program that Euclidean and non-Euclidean geometry be seen as exceptional cases of projected geometry. In each case, the common features that, in Klein's opinion, define them as geometries were a collection of focuses referred to as a space, and a set of adjustments that allowed figures to travel about inside the space without changing their basic properties. For example, in Euclidean plane geometry, the commonplace plane is a space, and the transformations are rotations, reflections, translations, and their composites, none of which change the length or point of a figure in Euclidean geometry. The figures would have basic properties and different geometries would have different spaces.
Reflection. Reflection is a transformation representing a flip of a figure. Figures may be reflected in a point, line, or a plane. 4 rules of reflection. Rule number 1, reflection over x-axis, is that when reflecting across the x-axis, we keep x negative. No, we keep x same but makes y negative. And rule number 2 is reflection over y-axis, is that when reflecting across the y-axis, we keep y the same but make x negative. Rule number 1 and rule number 2 are opposite to each other. Now, rule number 3 is reflecting across y equal x. When reflecting over the line y equal x, we switch our x and y. This reflected point represents the inverse function. The last rule of reflection is reflecting across y equal negative x. Is that when reflecting over the line y equal to negative x, we switch our x and y and make both negative. So rule number 3 and 4 are opposite to each other too. How can we connect the reflection to our daily life and how to relate it to other subjects? Reflection of light, sound, and waves, water waves, is that reflection of light is the rear view mirror enables the driver to see things behind the car. And reflection of sound is that a wall or cliff. Echo is the repetition of sound, even the source has stopped vibrating. This is used by bats as well as dolphins for the detection of navigation and is related to science. This is our model for reflection, that the light is reflected to the mirror and the light of the mirror is reflected to the object. And now for rotation. Rotation is a transformation that turns the figure about a fixed point called the center of rotation. An object and its rotation are the same shape and size, but the figure may be turned in different directions. So rotation has some formula or rules. Our rotation of 90 degrees for clockwise and counterclockwise, and rotation of 180 for both, and rotation of 270 degrees for clockwise and counterclockwise. So how to relate or connect the rotation to our daily life and relate it to other subjects is that when Earth or other planets rotate on its own axis and is related to science, and the phase will rotate around the horizontal axis and causal rotate around the vertical axis.
The third type of transformation that we can make to an object is translation. Translation is basically the movement of an object from one place to another without changing its size or appearance. When undergoing translation, the object does not get flipped or rotated. Its position simply changes, and the size will be the same as before. This is an example of how we can track the translation of an object on a graph. So we can see that the second triangle has moved along the vector 3, -8, which means that the x values each moved 3 points to the right and the y values moved 8 points down. The next example is a reverse question. They gave us the points after the translation occurred, and we have to find the points in the beginning. In this case, we use the given vector 4, -1 and subtract 2 from our x value 4 and add 7 to our y value -1. And so we get the point P as 6 and 8. The last type of transformation is dilation. Dilation, on the other hand, changes the size of the object. It can either make it bigger or smaller, but it still doesn't cause a change to the overall shape of the object. So in this example, we can see that every coordinate of the original triangle has been diluted by a factor of 2. And at the end, the triangle still has the same angles on each of them. Now let's take a look at a longer problem. In this final question, we have to use 3 of the rules of transformation. In the first part of the question, we have dilation. So we can see that the image increased in size with a factor of 1.5. In the second part, we flip the resulting image across the x-axis because we have a negative sign in the formula. And finally, for translation, we move the image 1 point to the right and 2 points down the graph. A real-life model of this is a mirror. In this model, we can see how the same pen is a different size according to the mirror that you hold in front of. So in the first mirror, a simple normal mirror, we see the same size of image as the object, whereas in the magnified mirror, the image looks bigger. Another example is concave and convex lenses used in physics. Concave lenses tend to make the image appear smaller, whereas convex lenses make the image appear larger.
Now for our reflection, each one of us is going to talk about how they have faced this lesson and what are the hard parts they faced. Now, first of all, as in for me, I can easily understand each of the four transformations of functions. We have used many examples like the reflection of mirrors, rotation of bowls, and more than that. The hardest point I have faced in this lesson was the calculation, since I usually mess up the different processes if it's for rotations or reflections or translations. Idea?
My reflection is that I can easily explain the lesson of reflection and rotation, but my immediate point is that I am confused between the formula of rotation and reflection.
My overview of this lesson is that it contains a lot of calculations, which was probably the hardest part, but it got better with practice and we got used to the formulas of the different types of transformation.
Thank you guys so much for listening to this video of us explaining our lesson. And yeah, that's it.
Okay, I'm gonna ask the leader of the group to give us also a brief reflection for the whole group about the project. I think
I'll give
yes.
you the reflection instead.
Okay.
Okay, so our lesson was about transformations of functions. We chose this lesson because we can see it in our daily lives and it's an important concept in geometry. So this lesson was mainly easy. Some of the challenges were equations and formulas that we used for solving different types of transformations on a graph. And from this lesson, we learned the different places in our lives that we can see these transformations. For example, like translation in driving, or reflection in the mirror, and rotation in roundabouts on the planets. In this project, we used graphs and real-life models that we found around the house. And for our next project, we can create a bigger model that evokes the topic and includes our parts of the lesson, and which could be beneficial for our environment and society.
Thank you very much, Marcel. We still have one more group, the last group number 4.
At Fair project, we decided to build a website. The topic of our project is function graphs and absolute values. The process of the project took 2 weeks to complete.
The reason why we chose this topic is because we have been learning these lessons for the past few years.
Each of us had a specific task to do. We communicated through WhatsApp and Zoom meetings, and that's how we shared the ideas and informations that we gathered.
A challenge that we faced was how everyone had different schedules because of Ramadan, so we all found it hard to make time to finish the project. We hosted a Zoom call to discuss the topic, and then each student was assigned with a specific task. I was responsible for researching about the topic, like finding the history behind the topic and general information.
I was responsible for filming explanation videos about the topic and for editing our reflection video.
I took the responsibility for finding a platform to make our project, and I helped find the information about the topic.
I was assigned to find real-life examples related to our project, and I also came up with the ideas on how to design the project.
The graph of the function is the set of all points x and y, in the plane that satisfies the equation y equals f of x. If we can draw any vertical line that intersects a graph more than once, then the graph does not define a function because that x value has more than one output. The term function was introduced by Gottfried Wilhelm Leibniz, 1646 to 1716, almost 50 years after the publication of geometry. The idea of a function was further formalized by Leonhard Euler, 1707 to 1783, who introduced the notation for a function y equals f of x. What are the uses of functions? Functions are used for performing the repetitive task, or we can say the functions are those which provides us the better efficiency of a program. It provides us the facility to make a function which contains a set of instructions of the repetitive types, or we need them in a program at various places, thus a function. What is the importance of the graph of a function? The graph of a function is often a useful way of visualizing the relationship of function models. Manipulating a mathematical expression for a function can throw light on the function's properties. Functions presented as expressions can model many important phenomena. Graphs in medical. Doctors and healthcare professionals use graph functions daily. They use graph functions to keep the patient's health in check by controlling their vitamin levels, blood sugar levels, and cholesterol levels. Graphs in science. In physics and chemistry, graphs are used to study molecules. Graphs in general. Graphs are used to represent the routes between the cities. With the help of tree that is a type of graph, we can create hierarchical, ordered information. Absolute value refers to the distance of a number from zero, regardless of direction. The distance is always positive as the absolute value of a number cannot be negative. Use this term to refer to the distance of a point or a number from the origin, zero of a number line. Jane Robert Argand. In 1806, Jane Robert Argand introduced the term module, meaning unit of measurement in French, specifically for the complex absolute value, and it was borrowed into English in 1866 as the Latin modulus. The term absolute value has been used in this sense from at least 1806 in French and 1857 in English. What is the absolute value used for? The absolute value is used in the real world to define the difference or change from one point to another. A good example I found was that everybody is going 55 miles per hour and you are going 70 or 40 miles per hour. You will most likely get a ticket. It matters because the difference between you and everybody else is 15 miles per hour. What are the rules of absolute value? Absolute value equations are equations where the variable is within an absolute value operator, like absolute value x minus 5 equals to 9. The challenge is that the absolute value of a number depends on the number's sign. If it's positive, it's equal to the number, absolute value 9 equals to 9. If the number is negative, then the absolute value is its opposite, absolute value negative 9 equals to 9. Real-life examples. A geophysicist used absolute value to look at the total amount of energy used.
They use it in physics and calculus to define certain situations, like to know how far something travels.
After each student finished their assigned task,
we hosted a Zoom call in which we built our website.
We made our website using wix.com.
It's a platform which helps us create websites and share it publicly.
Hi girls, hi Mr. Amran. Sorry, I have just come towards the end. I didn't have a chance to see anything, but I'm sure I trust you girls.
Hi, Ms. Marwa. Thank you very much for joining. Ms. Marwa, we are looking for your reflection, and I know you got chance to just go to other exhibition, and of course you have ideas what's going on. So we are looking for your reflection.
Yeah, I just want to thank you from the bottom of my heart. Guys, really, we're working very hard. Starting from teachers, Mr. Amran, the whole math team, Amran, Abdul Wahab, Radwan, of course, Miss Nighat. So much appreciated. Really, girls, you were coming, you were fighting the pandemic and coming to school to shoot the videos. I'm so happy to see you excited. I didn't have a chance to watch anything of what you did, but I trust you and I trust that you did something I will be proud of. I'm proud of what you're doing anyway. So really, really thank you so much from my heart. Inshallah, I will be there in the awards, Mr. Amran, inshallah. When you give
Inshallah. Thank you very much, Ms. Marwa. Thank you very much, Mr. Umran. All grade 11 girls, thank you very much. I have seen your exhibition, your journey, your projects, your videos, your reflection, and everything is amazing. I can see the future mathematicians, scientists, doctors, engineers. I can see your creativity, your depth of knowledge about mathematics, and all thanks goes to Mr. Omran because this is his motivation and of course your effort. So thank you very much, everyone. If any parents joined today in exhibition, I want to say thanks to parents also because of them, because they allow this time to you, they motivate you. So of course you are able to perform much better today. If any parents is there, please, I want to listen reflection. If anyone is here, you can unmute and reflect. I think maybe they left. Okay, Mr. Rashid is here from math department. Would you like to say something, Mr. Rashid? No, I don't think so. He is listening. Thank you very much, Mr. Omran. And this was great journey for your students. Maybe if you want to say something at the end to your students.
Yeah, I say thank you for all of you, to all the work that you did. I think we have been working on this since 3 weeks. Many times they gave me work, I sent back, then gave me, then I sent back, till we finish this at the end. Thanks all of you for all your efforts you did during this time. I think it's just, we are doing this for the first time. Inshallah, grade 12 things will be more better than this, and sure in your future university will do a lot of things in this way that we will reach to the perfect projects. Thank you very much, girls.
Thank you,
Mr. Marwa. Girls, you can leave now. Inshallah, we'll meet in our classes. Thank you very much. Bye-bye.
Do you have boys now, Mr. Amran? Different link, right?
11:10 after the break.
After 11:10, خلاص. See you. Inshallah, I will catch you in the boys. I managed to see.
Hello, Mr. Amran. Sorry, I was having a session. I had to see most of the part of the presentation, and I'd like to say that this was a very wonderful presentation. Props to your students; they were really, really good, and I like really how detailed they actually went through the presentation and research. And mashallah, I can't say other than mashallah. Very, very well done.
Thank you, Mr.
Rashid. Thank you. Thank you.
Thank you, Ms. Nigar. Thank you, Mr. Maruf. Bye-bye.
Thank you, Amran. See you in the boys' session,
Sure.
inshallah. Bye
Thank you
for
very
now.
much. Goodbye.
Bye.